First of all, this video is going to be a bit controversial. I'm not saying for definite on anything in this video. This is something that's come off the back of another video made by someone else, and I'm just speculating here, okay? Secondly, I know that my sound has been said to be not great recently, and I don't know why that is. But I'm trying to get to the bottom of it, why the sound has not been very good, why it's been low. Hopefully I'm closer to the computer here, hopefully it's picking me up better. There's a lot of, there's background noise going on here, but hopefully it's not been picked up. Okay, I'm going to get into this. This is going to be, I'm going to give you a brief rundown on what this is, okay? So, this man, Hervé Riboni, right, he's a sailor, right? He's a sailor of almost 3 decades experience. Now, I'm going to link Taboo Conspiracy Trees video in the description. Hervé, Taboo has featured Hervé several times in the past year or so, and a lot of very good information has come out. Hervé is doing a presentation here on how the distances and speeds that are shown within the Vendée Globe race can only fit a flat Earth and do not fit a globe. He even goes as far as saying that the people who run the race would have to know that the Earth is definitely flat for all the data manipulations that they must do before they hand details to the public. What he's saying is that they'd have to know already. There'd be no way they could not know, according to him. And I would have to agree with him if what he's saying is correct, because he points out where the distances and the speeds and the locations of don't match a globe. The way that it works out is that it matches a flat plane. But this is the part I'm focusing on. He's stating that the con is in us believing, and he can correct me if I'm wrong about this. As I said, this is a controversial video. It might get taken back down, right? He's stating that the con is in the belief that, basically, without paraphrasing him too exactly, that the con is in that the nautical mile, we're under the belief it's greater than the statute mile, when it's actually could only be a portion of a statute mile, or even only half of a statute mile. It's because what he says is that within the equator line here, this red line, what he says is that that is 21,600 nautical miles. But he says that that's like, what he's saying is that the nautical mile is smaller. So instead of a distance in statute miles, let's just say from the center point here out to the equator, instead of that being 6,213 or whatever statute miles, it's actually only like a lot less than that, right? He's saying that the north, for them to create the globe, they had to make the north bigger and the south smaller to create the globe, and that's how they did it. So basically, it would mean that they're messing around with the ocean distances, and that's kind of what they're doing. And he reckons that the flat Earth, and he says you can kind of show it, that the Earth is definitely flat, but it's actually smaller than the globe. That the whole area is actually a bit smaller, but we're allowed to believe it's bigger. So I'm going to work off of that premise, and I've done some calculations on the Sydney to Santiago flight. All right. Now, as I said, I normally don't work off of, I normally don't care, I don't go into that because it's information from Qantas and Latham and other airlines that you're not going to get off of them. They're going to give you whatever they give you. If you ask them specific questions, you're not going to get answers because they're private companies. They keep everything behind a security wall. But going off of what Hervé has been saying, if I use what he's been saying, it actually works out just fine on a flat plane. I'll show you what I mean. Now, as I said, this video is controversial, might get taken back down. I might end up just deleting it, but it's worth doing just to see, right? And Hervé is coming out with another presentation soon, with what he says is the start of an actual proper map with proper distances, flat Earth map with proper distances. So either way, I get stuck into this first. There's a lot of maths in what I'm doing. I'll explain what I'm doing, right? The time difference between Sydney and Santiago is 14 hours, but you can't use that to find the distance between them using latitude and longitude, because that's what I need to do. I need to get a distance between the two locations. So 14 by 15 is too much because it's more than 180 degrees. So when I use the remainder of 10, right, that'll be 10 portions of longitude at 15 degrees of longitude between them. So 10 hours, right? So that's 10 time zones. So 10 by 15 is 150. 150 from 180, because we're going to be using triangles, leaves us with 30, right? And we divide that by 2, we have 15, and that gives us angles of 150, 15, and 15, right? So just to show you what that's about, right? It would be this, right? That would be the 150, and that would be each one of those would be the 15, okay? So that's 150 is the big one, and this would be 15 and 15, right? That's giving us 180 altogether, right? But, oh, sorry, sorry about this. I just have to find that I'm losing the screen I'm looking for. Must be gone behind that. There we go. But the way I'm going to work it is I'm going to have to break that into two. So 2 right-angle triangles. So just to show you what I mean. So I'm going to break this into 2. So I'm going to split this triangle here into 2 right-angle triangles to figure out the distance along this blue and along this red line. So if I divide that by 2, I end up with internal angles of 2 separate right-angle triangles of 75, 90, and 15, right? Now, here is the latitudes for Sydney and Santiago. They're very, very close, which means that, right, they're very, very close. So how I'm working it, how I do this is I'm taking a distance from the center point, right, out to that latitude, right, on each one, right? And I'm then going to determine the distance between the 2 locations using those 2 lengths and the angles, okay? But I'm going to go through what I do, right? It's totally fine. And some of you might want to use the same process. But this is how I find the distance on, let's say, a flat map using the latitude and longitude grid, and using different sizes to or lengths to nautical miles. So I split this in 2, which gives us 2 right-angle triangles as opposed to one big, not scalene triangle. I can't remember the name of the triangle I'm thinking of now. I suppose it is almost a scale. Well, I don't know if I can't remember the name. Hang on 1 second. I'm going to get the name of the triangle I'm thinking of. I think I have someone here. Did I get a triangle something? I thought I had it. Don't worry about it. I'm not going to go into it. But so the difference, if we take the difference between 33, which is Sydney's latitude is 33.8688. Santiago is 33.4489, both south. That leaves us with a deficit of 0.4199. We multiply that by 60, it gives us 25.194 nautical miles. So that's the only. So what that means is what I'm trying to show there is the difference in length from the center point is only 25, just over 25 nautical miles. So from that center point to Santiago and then out to Sydney, there's only a slight difference in length on the Sydney side. But I'm going to account for that anyway, so to make sure that the borders aren't making a big thing out of nothing. Okay, so that works out as 25.194 nautical miles. So first thing I'm going to do is I'm going to make make a distance based off of, this is how I do it, right? So you understand. So it's not just I'm going to start with the Santiago. So I'm going to take a length from the center point here to Santiago, and I'm going to duplicate that over here. So this other length won't reach Sydney. It'll be 25 miles away from Sydney, right? And from there, this is, right, so I'll have 33.4489 by 60, right, which is 2006.934 plus 5400, which is 7406934, 7,406.9 nautical miles. So each side of both triangles, or both sides of main triangle, will have a length of 2006.934 nautical miles with the 5400. Each right triangle will have one side length of I meant to change that there, sorry. One side length of 7,406 nautical miles, and internal angles of 75, 90, 15 adjacent. The adjacent then would be 7,154.54. The hypotenuse of that right angle triangle is 7,406.934, and the opposite is 1,917.0555, right? So again, that means that my adjacent is my length, right? The length, the adjacent will be this length to the center, right? So now I must double that to get, once I double that, I'll get the full length, or let's say of this blue line, right? So I double that by 2, and it gives me a distance between the two locations of 14,309.097 nautical miles. Okay, now I'm going to do the same thing with the distance, but I'm going to use, instead of using the length from the center point to Santiago, I'm going to use it from the center point to Sydney, right? That will give us, I have it over, it's out of scale here on this, here what I'm showing, but just so you can see it, I'm using the blue line as if it's using the Santiago distance, and the red line as if it's using the Sydney distance. So that means we're going to have a slightly greater distance with the Sydney line, but I'm going to do the same thing with the two right angle triangles. So here, 33.8688 by 60 is 2032.128 plus 5400 is 7,432.128 nautical miles. Each side of both triangles, or both sides of the main triangle, will have a length of 7,432.128 nautical miles. Each right angle triangle will have one side length of 7,432.128 nautical miles and internal angles of 75, 90 and 15. The adjacent is 7,178.88 whatever. Hypotenuse is 7,432.128, as we already know, and the opposite is 1,923.57, blah, blah, blah. So that means that our actual length of our right angle triangle is 7,178, but we must double that because that's only half of the full length. So we double that to get 14,357.76 nautical miles. Now, this is the thing. So we must find out exactly what the distance is. Now, they're very close, right? So we have 14,309 and we have 14,357. There's very little in it, but just to be somewhat correct, and I know all the ballers love to jump on stuff like that, so that's why I always try to be correct. What I'm going to do is do this two ways. I'm going to take an average. So I'm going to add this length, which would be using the Santiago lengths, and this length using the Sydney lengths, which gives us a total length of 28,666.86644. But I must divide that by 2 to get an average. That gives us 14,333.43322 nautical miles. So as an average, right? So, or if I use a scalene scalene triangle with side 1 of 14,357.76, side 2, side of length of 25.194, and angle 1 of 15 degrees, that gives us 14,333.437. Right, so there's literally very little in it. So up here is 14,333, down here is 14,333. The only difference is in the decimal point. So just doing it by an average or doing it with a scalene triangle, it works out basically exactly the same. Right, it won't matter right now, right, if there's a slight difference. So, but either way, I'm going to use the one of the scalene triangle. But this is the thing, right? Right. If the equator is 21,600 nautical miles, as Hervé reckons it is, so in other words, it's not 33,000 plus nautical miles, which it would be if every statute mile or if every nautical mile was 1.1508 statute miles, then that would mean if we take the equator as 21,600 nautical miles, I can't guarantee it is, don't know if it is, it's just the size that's given to us on the globe, right? But he reckons that actually could be correct, and he reckons he can prove it, but it's actually flat, not spherical, right? So if the equator really is 21,600 nautical miles, so we divide this by 9, that gives us 2,400, and we multiply that by 1.433225, and that gives us a radius of 21,600 nautical miles. The radius of that circumference is 3,439.74 nautical miles. So if we then multiply that by 1.1508, we get 3,958.452792 statute miles. That's basically the 3959, right? That radius, right? But their radius, remember, comes from the center point out to their equator. Their radius is not along, obviously, it's not a distance, they're not taking a distance along their curved arc surface. But the whole point that Hervé is making is that the center is actually a lot smaller as opposed to on the globe where the center is really big. The north of the equator and south of the equator are equal in size, where he's pointing out that north of the equator is much smaller than we're led to believe, and south of the equator is much bigger, but it's totally flat, right? This is what Hervé is pointing out. So if we use that 3958.452792, or the almost 3959, as the actual flat distance, so just to show you, it would mean that between here and that equator is actually only 3,959 miles. That's the actual radius, but it's flat as opposed to spherical, right? This is his point. And it's much bigger outside of there than inside of there, right? So the globe makes both the distance between the center here and the equator and 90 south equal in size, whereas he says no. He says, and he can show this, and he can show this even with the Van de Globe, and he's going to show it further and further, that no, all this has been messed with, right? According to Hervé, he seems to be putting stuff forward. I can't outright argue with him right now because I haven't been out on the sea to establish whether or not what he's saying is 100% correct. But he seems to be able to show with correct data from the Van de Globe race that that he's proving his point, right? So I'm going to go with it for the time being. But it means that this is flat. This whole thing here obviously is flat, but the distance between the center point and the equator is not 6,213 statute miles, but instead is 3,959. So, right, I know I'm throwing out a lot of maths, but it will make a bit of sense at the end. So what I must do then is that still means that there is still 5,400 nautical miles. See, the thing about it is that you're still going to be measuring that distance between the center point and the equator in nautical miles, right? There's still going to be 5,400 nautical miles between the GP of Polaris, let's just say, and the equator. But each nautical mile is a lot shorter in distance than we're led to believe. This is what from what I could gather, that's what he's saying. So if we take that and we take the 3958.452792 as the actual statute mile distance, but there's still going to be 5,400 nautical miles because there's going to be 5,400 minutes of degree, right? From the GP of Polaris to the equator, you're going to have, as you move back to the equator, you're going to end up measuring 5,400 minutes of degree, right? So that means, because it's 90 down to 0, so that means that we're going to have to divide the 3958 by the 5,400. And that gives us a ratio of 0.733, which means that if we go by that a nautical mile is only 0.73304 of a statute mile, as opposed to it being 1.1508 statute miles, if you can see what's happening. So one nautical mile is only 3,870.487 feet, as opposed to it being 6,076.224 feet in comparison with a statute mile being only 5,280 feet. So as you can see, if we do go off of this, then that means that the nautical mile is only a portion of a statute mile, as opposed to being more than one statute mile. That's the point. So it's smaller than a statute mile, not bigger. Which means that the ratio between nautical mile and statute mile is not what 1.1508, but 1.3641, and it's opposite. So instead of, if you want to find out statute to nautical, you're going to have to multiply the statute by 1.1508. If you want to find out nautical to statute, you have to divide the nautical by 1.1508. Instead, it's the opposite way around. If you want to find out nautical to statute, you have to multiply the nautical by 1.3641 right here to get the statute, or divide the statute by 1.3641. Or sorry, you'll have to divide the nautical, by 1.3641. I'm confusing myself, right? To get the statute. So it's the opposite kind of way around. I'm going to confuse you I'm going to confuse myself if I keep talking about it. But this is the point, right? That if you have 10 nautical miles, you must divide them by 1.3641 to get the statute miles, as opposed to before, to get the statute miles, you would have multiplied those 10 nautical miles by 1.1508. So yeah, I'm going to just to make it easy, just going to show you, right? It's the easiest thing to do, right? No messing around. So let's just go 10, right? So normally we would multiply, that's nautical miles, to get the statute miles, we multiply that by 1.1508, right? And that gives us 11.508 statute miles. That's what we're accustomed to, right? But Hervey's point is that this is wrong, that a nautical mile might only be half its current length, or half a statute mile. I can't remember exactly how we put it, but it's a lot smaller, right? From what I can gather from what he said, unless I have it completely wrong, which I don't think I do. But what that would mean is that 10 nautical miles would, if we'd have to divide them, instead of multiplying that by 1.1508 to get the statute miles, we'd have to actually divide it by 1.3641. I just 41, I'm putting all the numbers in, right? And that would give us 7.33 statute miles. So instead of 10 nautical miles being over 11 statute miles, 10 nautical miles are only 7.33, only over 7 statute miles. So you're talking a distance of 4 statute miles in the difference, as if you understand what I mean. So they've increased the size of the nautical mile in relation to the statute mile, from what I could gather from what he was pointing out. And I've thought of this, and other people, and even a QE said to me, that was the first thing I thought when it got to the subject, is that the Earth was actually smaller, not bigger. But because we're working off a globe all the time, we keep flattening out globes and making the whole thing bigger. And maybe that's not correct. Maybe it is correct. Maybe Hervey is not correct. Or maybe we're wrong and Hervey is correct. Right? Because I don't know, but this is what we're going to work off of. So you get the gist. So 10 nautical miles is less than statute miles now, not more. Right? That's the point. So, right, so if we work off of this, right, the ratio is different, right? It's not a 1.1508, but a 1.36. It's not a multiplication of 1.1, or it's not a division of nautical, the statute. It's the opposite way. I just showed. I'm confused myself again. So if we then divide, this is our distance, what we got up here, right? 14,333,437, right? 43471 nautical miles. If we divide that for this one here, right? We divide that by the ratio, right? We end up with 10,507 statute miles. Now, I know I've probably confused you, right? Maybe not, but I've confused myself. But we end up at 10,507 statute miles, as opposed to what would have been like probably about 16,000 or 17,000 statute miles, right? So if we use that ratio here, right, and we use the times of flight between Sydney and Santiago, and Santiago back to Sydney, this is the thing, right? This is another thing that's a problem, right, with that whole flight thing. This is why I only work off how the plane flies. I don't argue the flight itself, because I can't get all the information. I only argue how the plane flies, not stuff that I could only not an argument where I'd need information from the airlines themselves, which I can't get, right? But for this instance, I will use them, right? I will use that argument. So if they're flying from Sydney to Santiago, it's a 12.5-hour flight. But if they're flying from Santiago back to Sydney, it's a 14.5-hour flight. There's 2-hour difference, which, as we know, if you looked at the flight in any way in the background, they're using trade winds and different things like that, right? If you look into convection currents, you can see, and things like that, you'll see on the bigger scale, you'll see that there's a lot of currents moving around the Earth all the time, and they're so constant they can use them. So obviously there's some issue because of 2-hour difference, right? Going from Sydney to Santiago is only 12.5 hours, whereas back is, according to the official figures, and back is from Santiago back to Sydney is 14.5 hours. So between that would be 13.5 hours. So with a distance of 10,500 miles, right, statute miles, a 12.5-hour flight would have to have an average of 854 miles per hour, right? A 14.5-hour flight would have to have an average of 735 miles per hour to fly the distance of 10,507 miles. But if we take an average of those, which would be 13.5 hours, then that would be 790 miles per hour as an average, right? So the average time and speed for a flight from Sydney to Santiago or Santiago back to Sydney, the average time and speed would be 13.5 hours and a speed of 790 miles per hour. Qantas and Latham Airlines fly the Boeing 787s, which has officially reached speeds of over 800 miles per hour. Now, we don't know unofficially what speeds they can get to with the winds and whatever else, right? But either way, if we look at this as an average, it looks like it's very likely that if what Hervé is saying, and he seems to be proving somewhat, he hasn't totally proven it yet, so I'm not going to throw all my eggs in that basket. But if what he's saying is true, then that completely more or less explains the flight. Because I know for a fact that 787s can go 776 or 780 miles per hour, but they've reached speeds of over 800 miles per hour, and I'm sure with winds and that they can reach easily over 800 miles per hour. So this makes the whole thing a lot less of a mystery. But this is the thing: we don't know if a nautical mile is 0.733 of a statute mile, because Hervé was saying that I'm only going off of if the actual statute mile distance between the North Pole and the equator is 3,959 miles, right? If it is that, right, then what that would mean is that the plane would have to fly in somewhere between 850 and 330 miles per hour for those flights, right? Which it can do, from what they say, and using winds and that, I can't see how it's not possible, because the 787s can reach over 800 miles per hour. And they have no hassle stating that they can go 700, just almost 700, 776 or 780. So they could very likely do that flight. Very, very likely, just off of those distances. But this is the thing. But if a nautical mile is only half a statute mile, where one statute mile equals 2 nautical miles, then 14,333.43471 nautical miles equals only 7,166.717 statute miles. And if we take that and we divide that by 13.5 hours, we get 538. So that's an average speed of 538.85. Let's say 539 miles per hour. Totally any plane could fly it, right? But let's just take the 790 and the 538. So this is at a 0.7 of a 790 is coming from a 0.7 of a statute mile. A nautical mile being 0.7 of a statute mile, and the 538 is coming from the nautical mile being 0.5 of a statute mile. So let's do a medium. Let's do an average where we make it a 0.6, right? If it's a 0.6, then that would mean that the plane would only have to fly an average of 664.42 miles per hour, which is under 100 miles per hour less than they actually can fly. So if Hervé is right, and the nautical mile is smaller than we're led to believe, and is actually smaller than a statute mile, right? And that they've messed around with the sizes of the oceans, and maybe the land masses are kept somewhat correct, but the sizes of the oceans are not, right? Then if that's the case, then it's what I've just shown here. Shows that it's very likely that the whole Sydney to Santiago flight is no big mystery. As I said, this is the end of this video. As I said, I can't know for certain on any of this, but if it's proven that the nautical mile is a lot less than a statute mile, especially if there's 2 nautical miles and 1 statute mile, which would make sense to do with something else I saw concerning Egypt, then this there isn't a mystery. There isn't a mystery at all. So what I'm going to do is I'm going to finish this video. As I said, this could get taken down. It's only just it's a maybe, right? Just throwing it up there. As I said, I normally don't argue anything about flights and directions and times and all the rest of it, because there's information you're not going to get off the airlines. So you'd end up trying to argue, and I see it with other people trying to argue about flights when they can't get the correct information. They just have some claimed official information when there's other information that they can't get. And this is Hervé's point. This is his point concerning the concerning the Vendée Globe, right? This is his point that the race, the Vendée Globe, has been messed with so much that they end up giving people an average speed, let's just say. Oh, the average speed was like 20 whatever kilometers an hour. Whereas what he's pointing out is there's times when they're going way faster or way slower than that, and it depends on where they're doing those speeds and what direction they're going and where they are in relation to other things. So if you see it like that, then he's pointing out that airplanes are actually, according to him, very likely flying shorter distances and flying slower. They're not flying the distances and at the speeds that we're led to believe they are. That's not happening. It's still taking the time it's taken, but the distances and speeds, because they're all being done in nautical miles, are giving people the impression that they're much greater in statute miles when they're actually a lot less. So I'll leave this. I'll leave this now and see what happens. See what you think of it. And as I said, I normally only argue when it comes to airplanes. I normally only argue how they fly, and I'm unbeatable there because I know what they do and what they don't do. But when it comes to this, I don't normally argue it. But here, I think it's worth making the argument, right? Because if what he's saying is true, then problem solved. Not that there is a problem anyway, because it does happen, and planes can only fly over a flat plane. But just for the sake of shutting up a lot of stupid trolls, it's worth it. Right? Thanks for watching. I hope the audio wasn't too bad.